Let's now make a tour over the ChipProg-02 graphical user interface that enables control of CPI2-B1 device programmer. When you launch ChipProg-02 application for the first time, it prompts you with a wizard where you need to specify the programmer model, the mode of use, single-site or gang mode, and the programming interface, USB or Ethernet. The wizard ends with opening the startup dialog with pre-filled options. By clicking the Start Device Programmer button, we'll launch a single-site CPI2-B1 programmer. This will open the main window. By default, the programmer GUI opens 4 windows: Buffer Dump, Device Information, Device and Algorithm Parameters Editor, which serves for preparing the data to be written into the target device, and the Program Manager that concentrates the commands for device programming. Let's observe the main menu toolbar, located on the top. Most of drop-down menus are very similar to other Windows-based products' graphical user interfaces. Others include commands specific for the device programmer control. The File menu allows to load files to the programmer's buffer dumps and save the data from buffers to a PC hard drive. The View menu allows to open windows. Besides the default 4 windows, you can open more than 1 buffer dumps, and the console window, to which the programmer permanently streams its activity. The Project window allows to create, store, and manage programming projects. A project is a fundamental concept for the ChipProg ISP2 device programmers. Instead of using single steps, such as choosing the device to be programmed, browsing for the file to be written into the device, and setting other properties, it's much more convenient to specify all these options in a single project, store it as one project file, and then open this project file by one mouse click, or by calling it in the command line, or as a DLL parameter. The Configure menu opens several configuration dialogues. First, settings for data in buffers and blending dynamically changing data with static data, loaded to buffer dumps. Such dynamically changing data is often represented by serial numbers, checksums, and custom signatures. This menu calls the dialog for setting static IP addresses if the programmer is controlled from a local area network via Ethernet interface. It also includes commands for such miscellaneous user interface settings as fonts, colors, key mapping, sounds, etc. The Commands menu duplicates command lines listed in the Program Manager window. Here you can launch the self-test and to toggle between the full and simplified user interface. The Script menu concentrates the commands managing custom-made scripts in the ChipProg ISP2 programmers. The Windows menu controls position of open windows. The Help menu enables access to the built-in context-sensitive user's guide. License Management calls the dialog where you can see currently active device library licenses and to activate new licenses if they are purchased separately from the CPI2-B1 hardware. The very bottom option opens the panel that indicates the hardware serial number. The toolbar under the main menu line concentrates icons for frequently used commands. The right part of this toolbar displays major device programmer functions: check, program, verify, read, erase, and auto. All these functions, plus some additional ones, can be also found in the Device Manager window. If the GUI grays out some command button after choosing a target device, then this particular command cannot be performed on the chosen device. For example, some memory devices cannot be erased, but they can be reprogrammed right over the data written to them earlier. Let's begin from choosing the target device. Our device is the Texas Instruments ARM Cortex-M4 microcontroller. Click the Select Device button. In the pop-up dialog, you may either scroll down the device list, or to use the Search Mask field to find your device. Listed device part numbers are optionally accomplished with programming interface abbreviations. Some devices can be programmed through different on-chip interfaces. For our TI microcontroller, 3 alternative interfaces are available: JTAG, JTAG chain, and single-wire debug interface. The user should select one implemented in the target board. Let's opt the JTAG interface one and click OK. Then the software will reconfigure the programmer hardware to match the chosen device and programming interface and will automatically refresh information in all GUI windows and menus. A chosen device part number will appear in the Device Information window. In the bottom of the window, you may see a link opening the diagram displaying connection of a chosen device to the device programmer. Click the link and the connection diagram and cross table will open in your browser. Let's now consider how the CPI2-B1 interface enables preparing data to be written into the devices. The programmer merges static data and dynamically changing one. Static data, in turn, comprises of the data loaded from the file to buffer dump, mixed with the data set by the device and algorithm parameters editor. Dynamically changing data unique for each single device is usually represented by serial numbers, checksums, signatures, etc. Some devices may have memory belonging to a single layer, but others may have memory belonging to several layers. For example, a chosen TI microcontroller has two memory layers, code and EEPROM. The GUI enables opening as many buffer dumps as you need. It's convenient for observing different memory ranges of the same memory layer at the same time, or different layers, for example, code and EEPROM here. The buffer dump windows have their own toolbars for frequently used operations with data loaded to the dumps. The data can be loaded from a computer and then modified manually. The Setup button opens the dialog changing the data format. The Block button is a dialog allowing several operations with data blocks, search options, and others. Later, data from the buffers will physically move from a computer to appropriate target device memory layers by the commands accessible from the program manager. Normally, contents of memory buffers represent results of the project build made by application developer. Project files, programmable to the target device memory, is stored as files in different formats. These files represent static data that should be written into a series of devices. However, sometimes you may need to write in each single device one or a few bytes that represent a unique piece of data, such as a serial number, custom signature, checksum, a scanned barcode, and others. The programmer's software is capable in slipping such dynamically changing data into the static data, mostly into the code. Besides dedicated parameters, such as a serial number, checksum, and signature string, the programmer enables operations with custom shadow areas for preparing the data calculated specifically for the case. For example, this can be a unique MAC address of the current device to be programmed, or a unique barcode that labels the current board to be programmed. However, before programming a device, you may tune some parameters without rewriting the entire project. This mechanism, implemented in Device and Algorithm Parameters Editor window, is convenient for changing such device-specific parameters as fuses, bootloader parameters, registers, programming voltages, clock frequency, and so on. The top part of the window lists default values of user-changeable device parameters. Clicking the parameter opens the setting dialog. The dialog appearance depends on the parameter type. Some of them have only two states and can be toggled, enable-disable. New values for other parameters can be typed in manually. Besides programmable device parameters, you can also make some changes in the device programming algorithm. For example, for the selected device you can change the clock frequency or VCC voltage. The software will block your attempts to exceed the ranges allowed by the device manufacturer. The window displays modified parameters in red color and issues the C help prompt over the red strip. It warns that the changes made within the editor window will not be immediately reflected inside of the device memory. They should be programmed by a separate command in the program manager. For the selected device there are as many as 3 program commands: for the code, for the EEPROM memory, and for option at project, that conducts physically writing parameters preset from the device parameter editor into appropriate location inside the device. The command tree in the Program Manager panel displays all single commands available for the selected Texas Instruments device. In most cases, especially when the device programmer is used for mass production, the user wishes a programmer to launch a certain sequence of the commands at once. This mechanism is implemented in the CPI2-B1 through the auto-programming macro command that bundles single commands in one chain. Clicking the Edit Auto button opens the dialog that enables modifying the default auto-programming macro command. Any single command can be added to the list or removed from it. While operating with one CPI2-B1 device programmer, a user can execute either the auto-programming chain of single commands or a single command itself. However, if you drive multiple CPI2-B1 programmers in the gang mode, you can execute the auto-programming only. Besides, the Programmer Manager window has 2 more tabs, Options and Statistics. The first one enables splitting data from the buffer dump to program them to multiple devices, reversing the order of bytes to be programmed and checking the device ID. The Statistics tab displays the results of programming and enables to limit the number of devices to be programmed in one session. Now, after reviewing the GUI for a single CPI2-B1 programmer, let's talk about use of multiple CPI2-B1 programmers for flashing multi-PCB panels in mass production. Virtually unlimited number of CPI2-B1 programmers can be controlled from one computer in the gang mode, flashing multiple devices in parallel. The picture here displays a cluster of 4 CPI2-B1 programmers mounted on a DIN rail. Let's now launch a pair of CPI2-B1 programmers in gang mode. To do this, we must check the gang mode checkbox in the startup dialog and to specify the number of programming sites. Launching the programmer with the chosen options opens the CPI2GX main window. The appearance of this window is the same as a single-site CPI2-B1 programmer with one difference. The Program Manager tab displays 2 sites. The gang mode, if it's controlled from the ChipPro-Go2 Graphical User Interface, has the following fundamental restrictions. Only the same device type can be programmed on all sites. All the sites must share data loaded in the same buffer. Only the same auto-programming batch of commands can be executed on all the sites. The ChipPro-Go2 software enables bypassing these restrictions by running multiple programmers in the standalone mode or by driving them through the application control interface or in the command line mode. Let's now return to the Program Manager panel. Since the gang cluster can execute the auto-programming function only, all the buttons launching single commands like read and write on the main toolbar are inaccessible and grayed out. Clicking the Auto button, the only one accessible on the toolbar, triggers synchronous executing of the same auto-programming batch of commands on all sites. For independent control of each site, they all have individual execute buttons. We've just reviewed basic operations with CPI2-B1 programmer accessible by the Graphical User Interface. In many cases, the GUI is used not for the programmer direct control, but for presetting other methods of control that are more suitable for integration of device programmers in test fixtures and automated test equipment. Such methods include, but not limited to, the standalone mode, the use of the application control interface, SDK, and so on. Usage of these methods of control are subjects for other video blogs.